Good morning or good afternoon, everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Ivan from Business Review, and I will be your host. It is our pleasure to have Pilgrim International with us today, who will be presenting this webinar entitled Overcoming Bolting Issues in Gas Turbine Couplings. Today's presenters are Damien Lewis, General Manager, and David Charles, Engineering and Development Manager. Before we begin, I'd like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason at all, just follow the link that you received via email to rejoin this session. If you have any questions, please submit them in the questions box, which is to the right-hand side of your screen. I will highlight it for you, and we'll allocate some time at the end of the webinar so we can answer them. If you're having any technical issues, please use the yellow help widget and know that you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. And I would like to give you a brief introduction of our speakers. Damien Lewis. Damien has been responsible for the running of Pilgrim since late 2017 and has vast experience in both production and sales management in a career expanding nearly 35 years. A time-served mechanical engineering apprentice, he started his career as a production engineer in the manufacture of reciprocating compressors for the oil and gas industry before transitioning into a sales career, focusing on roller bearing and then lubrication systems before joining Pilgrim International. David Charles. David has vast experience in the bolting industry and has worked at Pilgrim for over 25 years. In 2015, after years of design and field service experience, David took charge of the engineering and development team. In addition to his successful engineering career, David is a keen rugby league fan and spent several years working in the professional game as a statistician for Oldham RLFC. But now let me hand over to Damien Lewis, who will begin this presentation. Damien, over to you.
Ivan, thank you very much. And good morning or good afternoon to all participants. We will go through a number of topics today, as Ivan has suggested before, about gas turbines and bolting in gas turbines. And we'll spend about the next 45 minutes going through who are Pilgrim, what are the general trends that we see in gas turbines, the current gas turbine bolting solutions that are on the marketplace. Then we'll talk a little bit about a Pilgrim solution that we hope can be interesting for you. And then at the end, we have some summary and questions. And before I go through that, I just want to let you know that we would like some participation through the event, either through questions, as Ivan has shown you, or we have a couple of areas where we have some multiple choice questions, which we would like you to participate in. And we'll give you details of that as we get to those slides. So, who are Pilgrim International? I'll give you a brief insight into who we are. So what do Pilgrim do? We are an engineering company that has a vision to create a world of trouble-free connections. And we focus primarily on high-integrity joint fixings, whether that's static or rotating. And we have a number of technology platforms that can support this. We have the boltings and positioning offer that we have that we'll talk to you a little bit about today. We also have bolt tensioning systems, hydraulic drive-up systems. We provide a number of services into the market, training and on-site machining. And we also have a hydraulics pack offer to support the installation and the use of the majority of our products. We're a company based in the UK. We have manufacturing in Sweden, and we sell to over 55 countries directly over a large number of years. And we work through a number of agents and distributors, so we try to reach out to everybody in the marketplace. How do we do it? We're a company of over 65 years in existence, and in that time we've created or gained a lot of experience through creating known friction into systems. We have a strong experience of oil injection methods, and we also have a good knowledge of material expansion, which my colleague David will show you a little bit about in the product that we show later. We're also very experienced at working with high pressures, and what we mean by high pressures is around about 2,300 bar, and we know how to seal mechanical systems using these high pressures. And then we also couple that with a vast knowledge of some of our key industries, such as marine, or in this case, power generation, which we'll talk to you about today. But why do we do it? We have a passion, and our passion is removing uncertainty for our clients. And what we mean by uncertainty is reducing unplanned costs. So we like to create systems and solutions that are predictable and reliable. And what that means is that it improves the operating income for our customers. And also, we like to try and improve the performance of our customers' assets as well. We do this through a number of industries, and I can highlight some here for you. So we work a lot in the fuel industry, whether that's nuclear or fossil fuels or renewable energies, which is becoming more to the fore, through the marine industry, but we work a lot in heavy industries and also some very specialist applications as well, as you can see in the top right-hand corner with telescopes as an example. Very high precision, very accurate applications. So just want to highlight, here's some key customers or clients that we work with through different industries. And as you can see in the top section, we deal a lot with power generation, and whether that's the turbine OEM companies or whether that's the end users, the people who are actually using the equipment, we work with all areas of the business. And that really helps us gain a lot of knowledge and a lot of experience about how our product can positively impact our clients. So now what I'd like to do, now that I've introduced Pilgrim, I'd like to just talk a little bit about how we see the trends in gas turbines. And if I start with the macro view, the larger picture on what's happening globally, what we can see is that there is a lot of focus on decarbonisation, and I don't think I need to go into too much detail about that. If you just watch the news, I think you can see there's a lot of that going on at the moment, and rightly so. But what does that mean? We see that there's a lot of focus on transitioning from fossil fuels to renewable and reliable sources of power. What this means is that there is a transition away from coal generation. And I saw a phrase the other day that it will be ultimately outlawed. So through government activities, the use of coal will become less and less. So what that means is we see a lot of transition of power plants moving from coal and converting to combined cycle power plants, as an example, and the use of natural gas. And we see that will be a bridge until the new technologies that we're talking about, such as hydrogen, come on board. And then we also see that there's a mixture of blending hydrogen and natural gases together. And that's a big activity for the turbine OEMs to come up with solutions on how to manage that transition of increasing the blend or the reliability on hydrogen and reducing the need for natural gas in the future. And then we also observe that nuclear is making a comeback from the last 20 years of having some bad press. Now it's being reconsidered as a reliable source for energy again. So if we then look what that means specifically for the challenges of gas turbines, we see that the gas turbine business will maintain and increase over the next 10 years or so. There are some aggressive targets for gas turbine development. So there's a lot of activity on how to improve. And where we see those are through efficiency improvements in the gas turbines, and I'll explain a little bit about that in some slides to come. The compatibility with renewable energy sources and the pressure that will put on gas turbines is the ability to start up quickly and bridge the gaps where renewable energy sources can't meet. Maybe, for example, as a wind turbine, if there's no wind, we still need to have energy. Obviously, a flavour of the month is CO2 emissions, the reduction of those to support the environmental impacts. And then fuel flexibility. I mentioned about the mixture of hydrogen and natural gas together. And this has an impact on the turbine, the way the turbines are designed for jet. And also, gas production or gas power generation also has to be competitive against the renewable sources as well. So it has to be cost effective. What I'd like to talk a little bit about now is how we see the market. And what we can see here from this graphic is that the gas business or the gas turbine business will increase from 2018 to 2027. And if we look at a little bit more detail, we can see that there's quite a lot of growth in the dark blue area here that I'm just highlighting now. And that is in turbines that are 250 megawatt plus. So we can see that the majority of the growth expectation is coming from larger turbines. And then what we can see is that there's three major players, GE, Siemens, and MHI, and they'll produce between 2018 and 27 around about 3,000 gas turbines. 3,000 gas turbines. And that will be about 90% of the market demand. So there will be three major players. So what we've done is we've plotted here the gas turbine units of those three major manufacturers. And along the bottom, we've put them against their megawatt outage that they're designed for. And you can see that obviously in gas turbines, from very small units all the way up to nearly 600 megawatts. But what I'd like to highlight here is the fact that these turbines have all been produced or designed within the last few years. So we can see the trend for gas turbines increasing in size to support the demands of customers. And that has a relevance on the bolting solutions that are out there in the market. And we'll talk a little bit about that as we go along. What has happened over the years is that turbines have benefited from step change increases. And here we give a few examples, but I'll highlight here the SGT6 turbine from Siemens. And it was first introduced in the market in the early 90s, and through some evolution and continuous improvements, you can see it against the scale of the net power output in megawatts, the turbine has increased. And that's a natural progression as product develops and goes on. However, what that means for the bolting is that the bolting needs to cope with more torque going through the system. So the bolting solution that was designed back in the 90s might not be the right bolting solution in 2016. So what I'd like to do now is just spend a few minutes to talk about the basics of coupling bolting. So what is the basic activity of a coupling? And its functionality is basically to transmit torque. And when you have a flanged coupling, you need to bolt it together. And I'm going to explain two methods that we see in the marketplace that are quite common. You have friction-driven solutions, and basically they are a low-cost solution that are transmitting actual preload by clamping the two coupling halves together. And through friction, that drives the torque through the system. the things that we see here is that they create small transmissible torque. So they can only really be successfully used on smaller turbines. What we then see is a shear-driven solutions. And the solution that we're showing you here is a combination of shear and friction, denoted by the red areas here. And how that works is the transmission, torque transmission is actually transferred using contact area between the bolt and the couplings to drive the couplings, both through the diameter of the bolt, connecting with the bore of the coupling, and also through the face of the nuts to the coupling as well, intentionally. And again, this seems like a really good solution. However, there's some issues that we can see, and I'll explain those as we go into the next slides. So first of all, I'll talk a little bit about the friction solution. It's low cost solution, and it's very common in the marketplace. The issue that we see is that it can create unplanned costs because the bolting solution can fail. And what we mean by fail is that there can be stuck bolts. So when the bolt is in situ and actually in operation, there can be some shock loads that are created, which means that there's some micro movements. Because there's clearance in the system, there's some micro movements, which means that the bolt can get jarred and get stuck. And with that comes some downsides of trying to remove the bolt and some additional costs. The other issue that we see is that each bolt in the coupling cannot be uniformly loaded. So there's some difference between each bolt. If we then look at the shear solution, these are called fitted bolts, but in the main, they have some element of clearance to be able to assemble them into the hole, even if it's just a very small dimension. However, there is some clearance. And what we see as well is that when the bolt is actually tensioned, this also stretches the bolt. And what that means is that the diameter of the bolt, the shank diameter of the bolt, which should be in contact with the coupling, can actually reduce in size slightly, creating an even bigger clearance between the coupling and the bolt itself. And what that allows is for micro movements under dynamic loads. And what that then means is that the bolt can actually then angle itself and get stuck. And again, creating a stuck bolt situation when trying to decouple. So we often see that there's a seized bolt situation with these solutions. So if that doesn't happen very often, is that really a problem? But what we can see here from these pictures is that it can be quite catastrophic. In the top left-hand corner, you can see a bore that has been damaged by micro movements, and then the bore diameter, the bore material has started to fleck away. In the second one, you can see some carburization where oil has got in and then heated, and that's not very friendly towards the bolting solution and trying to remove the bolt. It actually sets like concrete. When you're tensioning bolts or torquing bolts, you can see here that there's face damage on the third picture, creating damage on the coupling face. And then if you do get an unfortunate situation where you have a bolt stuck, you can damage the bore trying to remove it. And here you can see some real clear damage to the bore diameter. And then if you do get stuck bolts, quite often you have to use methods, as you can see in pictures 5 and 6, where we're actually having to acetylene torch the bolt out to destroy it, to remove it. And in the last picture, there is a specialist company that's been brought in to drill through the bolt to remove it. And obviously that means on cost, but also replacement product as well. And all these have a major impact on safety as well. These are all activities that we don't want our operators to be doing when they're having to decouple. So, as I said before, so what if this happens infrequently? But in our experience of being in the power generation business for over 35 years, we don't see this as an irregular occurrence. And we undertook a survey in 2020, and we asked one very simple question to a user group of gas turbine users. And it was basically, how often do you experience seize coupling bolts when you're splitting a coupling during an outage? And the feedback was quite alarming, but not surprising. We saw that 80% of people splitting couplings actually experienced some level of stuck bolt situation. And of that 80%, 50% experienced it very often. And this is really why Pilgrim exists, because we want to solve this issue. We want to have a situation where our customers and clients don't experience stuck bolts, because we recognize some of the pain that this causes our customers. So before we move on to a small quiz, I'd just like to do a conclusion on this and show you what we see as regular bolting solutions that are in the market today, or the types of bolting. I talked a little bit before about friction and shear driven solutions, and what we see is the classic torque tightened clearance bolt. And what we see is that, again, just to summarize, that it transmits low frictional forces. The coupling, it can create coupling damage on the couplings, and it's very common. It doesn't retain its loads, or it's inaccurate, and we see that coupling slippage is quite common, especially when you hit some dynamic loads coming into the system. So what we then see is that some companies have actually created a hydraulically driven friction bolt. And these need massive preloads. And what that means is that the solution is designed right to the end of the envelope of its operational ability. And it needs that to create the preloads. But that comes with some risk, because we see that you need quite a lot of safety equipment, which can be quite bulky and quite complex to manage. There's a puller, which I'll just highlight here. And because that is put under quite a lot of stress when it's used, there is a finite life and needs replacing. There's a very low factor of safety. So again, if the system experiences some shock loads, then the bolting can quite often get stuck. So what we see is some people driving towards using shear bolts, because in theory, it's a better solution. And we see what we call fitted bolts. And as I mentioned, these are normally not truly fitted. And David will explain a little bit about what truly fitted means in his section. But what we see is that when you have a hydraulically installed tension bolt, you can still get micro movements because of the clearance that's inherent in the system. As I mentioned before, the reducing shank diameter. And this also creates coupling slippage. And the coupling bore and face can get damaged. And then finally, we see an option in the market, which is called mechanically tensioned. And this is the first introduction that we'll talk about, where you see a sleeve introduced into the system. And this sleeve on the bolt is actually driven mechanically through a number of bolts that you can see in the end of the nut. And they then drive a sleeve through a taper to create a fitted bolt. And in theory, again, it's a good solution because it creates a fitted situation. However, we see some issues with the design as well. The nuts can be a little bit bulky because there's quite a lot of mechanical parts. And these mechanical parts are subject to failure if there's an ingress of dirt. It can be quite time consuming, because if you imagine you have a coupling with 24 bolts, you have 24 times 16 bolts to tighten up. And this can be quite time consuming. And there's no alternative removal method. So if the mechanical method fails, you're then stuck with actually drilling the bolting out. So that concludes my section. So what I'll do now is I'll move on to a quick question. As I said before, if you could give some feedback, that would be great, before Dave talks about the fifth option that we have, which is in addition to the four options that we've shown here. So if I could ask, it's multiple choice. Please feel free to answer. And all I would ask is that once you've selected, you just need to hover over the questions and click, and then there should be a submit button to cement your answer. So the first question I would like is, which bolt solution are you using today? Friction driven, shear driven, or others? And I'll just wait 20 seconds to give you a chance to answer. I'll just give another few seconds. Okay, thank you very much. So what we can see here is that there's a good mix, and this is my expectation, that there is a mix between the various solutions in the marketplace. So again, if I could just ask you to give your choices here. So the question is, in your opinion, what is the most recurrent damage to occur when removing bolts? And again, I'll give a few seconds for you to answer. Just a couple more seconds. Okay, thank you. And again, it's quite a mix, and you can see that 40% or thereabouts, so coming up to half, experienced all of the above. So again, this reiterates the commonality of the issue that we see, I would say. So thank you for your inputs there. So what I'll now do is I'll now say thank you for your time with me, and I will pass you over to Pilgrim's Engineering and Development Manager, David Charles, who will talk a little bit about Pilgrim's Radial Fit Bolt for you. Thank you.
Thank you, Damien. So, as Damien earlier mentioned before the quiz, there is a fifth option. Imagine a bolt, what is OEM approved. It's retrofittable, repeatable, predictable, reusable. Due to its design, it has an extended product life. It allows accurate outage planning during the critical path stage. It offers a quick return of investment. A bolt what's really easy to install, but even easier to remove. And it eliminates any coupling damage, so it avoids any costly redress of the application. So what is this bolt? This bolt is a Pilgrim Radial Fit Bolt, a true radial fitted bolt. And how does it work? Like most bolts, it works with two nuts, a bolt and a sleeve, but this bolt is a little bit different. It has a male taper, and within the sleeve it has a female taper, which corresponds with each other. and the bolt is designed to deliver the torque required for the application in both shear and friction combined. The bolt will carry the torque of the application mainly through shear, with a very small percentage through friction. So what really is the true benefit of this bolt? And we can see here with a great example of a 70mm diameter hole with 16 bolts in the coupling. And we like to define two zones: a safe zone where no slippage occurs between the flanges, and a slip zone where slippages occur. And when we talk about slip of the application, we talk about stuck bolts, because that's where it's likely to happen. And this is something what Pilgrim want to avoid. So we see a clamp bolt, a friction only bolt, a traditional bolt as we would call it, just sitting right just above the safe zone. Above that we see the Radial Fit Bolt, which offers a bigger capacity, around about 5 times bigger than the base load what a traditional bolt can offer. So what we see, as the power starts to increase, the torque capacity increases also. And it's very clear to see in this example that the clamp bolt, the friction only bolt, starts to slip as the power increases, where a Radial Fit bolt just carries on to around about 6 times the base load. And that is not just for operational torques, that also takes into consideration any shock or out of phase torques what can occur during the operation. So quite simply, how does this bolt work? So, like I mentioned earlier, we have a Radial Fit bolt with a male taper and a sleeve with a female taper, which corresponds to each other. The bolt is inserted in a clearance condition. And when we start to control expansion of the taper sleeve by using hydraulic equipment, we slowly position the sleeve within the coupling and we start to pull the bolt through the sleeve. And as we draw the bolt through the sleeve, it creates an expansion. And it's that expansion what gives an interference fit. Again, a truly fitted bolt. So we talked about not only does the bolt work through shear, the bolt also works through friction. And we do this by, again, using hydraulic tooling to create a controlled stretch of the bolt to put a load into the system. This high clamping load not only ensures that the coupling faces come together and create some additional torque to the system, but it also locks the round nut into place. And it's that high load what stops the nut from coming loose during operation. So no need for any anti-rotation devices, something what you can see on quite a lot of conventional bolting systems. Because everything is hydraulically controlled in a safe manner, there is no coupling damage. So again, no costs to redress the coupling, which not only costs time is money, but also getting expensive equipment onto site to redress that damage. And all in all, it takes less than 15 minutes to install and remove the bolt. So we talk about how easy it is to install. The true magic really happens when we remove the bolt. And we do this in a number of ways. We have a specially coated sleeve to aid removal. We then start to apply high pressure oil between the bolt tapered surface and the sleeve internal tapered surface. With that, the bolt will remove very quickly, and I will show you a video a little bit later of that process. But if that process was not successful, we designed a fail-safe where we have a secondary method to remove the bolt in a safe manner. And again, with all stages of removal, we ensure there's no damage to the coupling nor the product. And again, very quick to remove, takes less than 15 minutes to remove each bolt. So here, like I said earlier, I'd like to show you a quick video of how quick, using the oil injection method, the bolt comes free from the system. So as you can quite evidently see there, very, very quick and easy to remove a bolt. And I think we all can say that it's a lot easier and a lot better than trying to remove a seized bolt in the coupling. The frustration and the time that causes, we remove that uncertainty. Pilgrim, during the design phase and during production phase, we value your safety. And one thing what we try to do is that the bolting system, what we propose, is that there is no heat or freezing required. It's a simple operation, as we've seen for installing and removing. It's designed to be handled by one person, so safe handling, keeping weights down to a minimum, enabling one person to install and remove the product. We have optimized puller design and material. There's no safety features required, and I'll go a little bit into that later. The hydraulic vessels which we supply to deliver the hydraulic power to the system are all CE, UK CA marked. With the simplicity in removal, there's no need for cutting equipment, which again can cause a lot of issues with health and safety, and also getting permission to get that equipment onto site. So why Pilgrim? We have a proven history. Yeah, we have been manufacturing coupling bolts for 35 years of our 65-year history. We offer peace of mind. We've got our bolts in roughly 500 power plants worldwide, and this roughly equates to around about 25,000 bolts. And it's those bolts we have 0 reported design defects. So we're very, very confident, not just with our product performance, but also our quality. As Damien mentioned earlier in the presentation, we work with a lot of the OEMs, and they approve our product to be worked on their turbines. We have unrivaled after sales, whether that's technical support or field support. Pilgrim are always on hand to support the customer. So the technical advantage of our Radial Fit Bolt, we have design for excellence. And what I mean by design for excellence is that we utilise the latest 3D modelling software, and we fuse that together with the latest finite element analysis technology to ensure that whatever we design, we're designing the best solution for your application. We have a unique puller design, whether that's just the geometry, what we've optimized over the years, whether that's the material selection we use, the thread geometry. We ensure a puller which is safe to use. No need for a safety device. We've had 0 reports of any defects with our pullers. We have a specially coated sleeve, a double helical groove, and an oil injection adapter which has a hardened lens ring attached to it to ensure that we have a full sealing system against the bolt. Combine all 3 of those special features into our product, and that aids the removal. So we have a simple but effective removal system of the bolts, because we realise that is where a lot of headaches come for users when they come to remove product. So by combining those 3 technologies, we ensure a safe removal of the product. And finally, with all bolting, we only use the best approved mills for our material, which allows us to have full material traceability through the system. So we can ensure that the product what lands at the power station, the power plant or utility, we can be confident that the material is more than fit for the job. So I've got a question here. I've got 3 power plants: Kaiga generating station in India, Heysham 2 power plant in the UK, and Pickering Unit 7 in Canada. What connects these 3 power plants together? Well, the answer, at one point, they have all held the world record for continuous operations, with Kaiga generating plant being the current world record holder with 962 days. They also have another connection, and that connection to Pilgrim is vital. They are all equipped with Pilgrim Radial Fit Bolts, and we are proud that on all occasions when these units have been taken offline for necessary maintenance, all Pilgrim bolts were removed and reinstalled without any reported problems. Time, delays and any have been avoided, and the coupling has managed to get back online and generating electricity in such a short space of time, all in a perfect working condition. So, like Damien said right at the beginning of my presentation, or I think it was Ivan, I've been at Pilgrim for 25 years. I believe in the product, but just don't take my word for it. Just have a quick read of some of our customer testimonials from 2 power plants who've been utilising our product for a number of years. So, the bolting system, we like to say it's designed for life. And we design based on our field experience. And what I mean by that is that Pilgrim are a listening company. We listen to our customers, we value feedback. And myself and our expanded service team have been fortunate to travel to many of the power plants what have got our product installed. Working very closely with the operators of the equipment, we sit down and we take feedback. We take that valuable information and we put that back to the design team here at Pilgrim, and we continually evolve the product so we can take this product into the next generation by making incremental improvements all the time. We just do not sit back and keep the product as it is. We're continually evolving. So I would like to sort of end this presentation a little bit with a quick quiz. So again, I would like to ask a question with a number of multiple choice answers. I'd like you to spend a couple of seconds choosing your answer and then locking that in with the submit button. So question 1, which power plant has a world record for continuous operation? Kaiga generating station in India, Watts Bar in the USA, or Manshan power plant in Taiwan? I'll give you about 20 seconds before locking your answer in. Okay. So that's what I would expect. Yes, you're correct with Kaiga generating station in India. And yes, we're very proud that that holds a world record with 962 days in continuous operation with Pilgrim Radial Fit Bolts. I'd like now to hand over to our General Manager, Damien Lewis, who will conclude this presentation. Thank you for your time.
Okay, thank you, David. So, finally, just to say thank you to everyone for attending and your time. And before we open it up for some questions, I'd just like to highlight that we do have some other solutions that can support you in the marketplace. We have a coupling hole alignment tool, or a chat tool as we call it, for being able to quickly align couplings and to help with the coupling closure. We also have hydraulically installed clamp bolts that can work in combination with the radially fitted bolt in certain applications. As I mentioned previously, we also have hydraulic power packs to support all the installation of all our hydraulically installed products. We also have bolt tensioning equipment under the Hydrocam brand, and that for such applications as case closure systems. And we also offer a wide variety of services, including in situ line boring or coupling machining with a sister company called BFW. So what I would suggest now is that we open it out to questions. So if we just give you a couple of minutes to submit your questions, we'll just go on to mute for a minute, and then we'll come back in 1 or 2 minutes and hopefully answer the questions for you. Thank you. Okay, so we've had 1 or 2 early questions. Thank you very much. One of them that's come in is, what if you had a system, a bolting system on my unit? What stock items would you recommend to hold, and what should I do in advance of an outage to avoid any problems? Well, if I can answer that one, David.
Yeah, that's fine.
Okay, I think what we would suggest is there's a hydraulic system on our products, and what we would expect is some spare seals, just in case something was to go wrong there. It's quite rare, but it can happen for the hydraulic head. And as a precautionary measure prior to the outage, we would suggest that you just have a look at your toolkit and the pump to check that it's okay. And we do offer a refurbishing service on that as well. We'll just wait for another question to come in. So here's one. What is safety assurance for coupling removal within your system? So David, I don't know if you want to pick up on that one.
So yeah, a really good question to ask. You know, like I said earlier in my presentation, we really do value safety, and that's really at the forefront of our design. We actually do go on site and install this product, so obviously we want to keep everybody safe. You know, so what we do is everything we design, we make sure that it's been checked with whether it's through calculation methods, through finite element analysis, and then what we also do is that when we come to manufacture the product, we have a really thorough testing procedure. and then once that testing has been complete in our production facility in Sweden, we would then verify them results. And it's only when we are happy with the results we get from testing, we would release that out to be dispatched to the customer. We would not allow any product to leave our factory where we felt it was unsafe to use.
Okay, thank you. And maybe another question for you, David. What information do you need to offer a quote for you if I want to put it onto my unit?
Yeah, so if we was to design a bolt system, for your application, we would like the coupling geometry. What also helps us as well is that we understand sometimes some of these applications, they have a lot of space around the couplings, so it doesn't interfere with any installation or removal equipment. But we would like that information if there is a restriction. At Pilgrim, we design bespoke for the application. So if there was a particular restriction in mind, we would take that challenge on. But yes, we would need the coupling geometry, we would need any restrictions. We'd also like to know what the torque you would require through that coupling, both during operational conditions and any out of shock, out of phase torque, what that may generate. So it gives us a good guideline so we can guarantee the correct material selection for the bolting.
And I think also we talk quite often to the coupling OEM or the turbine OEMs, and we can work with them as well about the coupling geometries, can't we?
Yes, definitely. I think sometimes if the end user is struggling to get certain scientific information, like for torque requirements, etc., we have a very good relationship with the OEM who hopefully could provide that information to Pilgrim.
So someone's put a question here. Upon removal of the bolting on my last outage, there was damage to the coupling and I had to clear up before I fitted new bolts, which was also damaged. Would I have to do this if I was to retrofit your product in? Do you want to answer that?
Yeah, I mean, we've all seen damage what conventional bolting does. It's not nice, it's not pretty, and it can be damn expensive to sort of put right. But yes, to put the Radial Fit Bolt in and to get the full benefit of the Radial Fit Bolt, we would like the damage removed. Now, we can advise through either visiting on site or through videos or through photographs to analyse what is acceptable, what's not acceptable. But also what we can do is that we can also offer a full package for coupling preparation as well. On-site machining, sleeve preparation, and also on-site installation services as well. Now, not just installing the product, but we can also offer on-site training as well to personnel as well. So if they're new to the product, they've never seen the product before, we can offer the full package from coupling, remachining, to installation and training. Okay.
A question that's just come in is, how much costlier percentage-wise are your bolts than conventional ones used currently? That's very difficult to answer. I don't know what the cost for conventional bolts is. I don't know how much people are paying and on what we mean by conventional bolts. What I would say is that if you look over the life cycle of a radially fitted bolt compared to conventional bolts, the initial cost could be more expensive. However, when you take into consideration that you don't have to buy replacement parts and the product is completely reusable over a short period of time of splitting couplings and putting them back together again, any additional cost increase that you would envisage would be diminished completely. And I would say over a life cycle, you would probably be paying more for conventional bolts than you are for radially fitted bolts, especially if you're receiving stuck bolts situation. Do you want to add something?
Yeah, I'd like to add something a little bit further, Damien, and I'd like to ask another question on that is how costly it is when you have a conventional bolt what's stuck. Do you know how much does that cost the end user time and money when that does happen? That's where the Radial Fit Bolt comes in. It removes that uncertainty.
Exactly. Okay, so I think we've maybe one more question that's come in. What would I have to buy all the bolts again if I upgraded my current turbine to a newer, more efficient unit? Do you want to answer that?
Yeah, we get this question quite a lot, you know, and especially where they have rotor changes in power plants. What we do at Pilgrim, we would get the information from the end user, we would complete a full design review and see what implications that would have for the end customer. But again, not only do we design in safety in mind as well for our product, but what we will try and do as well is we will try to minimise the amount of parts, what would be required if there was additional parts, what were needed for that particular upgrade. So it may be that if the whole size is increased due to a rotor change, then it might be just additional sleeves what would be required. You know, it might need that, they may need a full new bolting system, you know. But what we would do that is would we assess that on us through a design study, which we would offer to the customer.
Okay, thank you. There's no more questions at this stage, so I think we're just about to the end of our time. So I would just like to say thank you on behalf of David and myself for your time. Hopefully you've enjoyed it. Hopefully it's been informative for you. We've really enjoyed talking about one of our favourite subjects, which is bolting and trying to remove uncertainty. And Ivan, thank you very much. I'll pass back over to yourself.
Thank you very much. I would also like to thank Damien and David for this was a wonderful presentation, and to Pilgrim International for sponsoring this session. To our attendees, you'll receive an email shortly telling you how you can access the on-demand version of this webinar, or you can also see it on our website, which is www.pmi-live.com. I would also like to point out that we have a few resources available for download in our resources list. So if you want, you can check them out. They are from Pilgrim. So thank you once again, everyone, for joining us today. And I wish you all a very nice day. Goodbye.